Hey y'all, it's Sarah. I'm back with another video in my calculus series. We are in the limits portion of this series, and today we're going to be talking about limit laws and the direct substitution principle. So first, I'm just going to go over some of our limit laws. So we're given here that c is a constant and that we have these two limits, both as x approaches a, of f of x and g of x. Both of these limits exist. So from there, we're going to start with sums and differences. So if we have the limit as x approaches a of f of x plus g of x or minus g of x, we can just separate this out along the plus sign or the minus sign. And so this becomes the limit of f of x plus or minus the limit of g of x. Next, we have a constant multiple, and so this is going to be the limit as x approaches a of c times f of x, and what we're actually able to do here is just pull the c outside of the limit. So this becomes c times the limit of f of x. Next, we're going to be doing the product of the functions, so the limit of f of x times g of x. Here, sort of similarly to with the sums and differences, we can just separate this out to be a product of the limit of x and the limit of g. Next, actually I'm going to take two lines for this. The limit as x approaches a of the quotient, so f of x over g of x. What we can do here is separate this out so that we have the limit as x approaches a of f of x over the limit as x approaches a of g of x, but this is only allowed if the limit of as x approaches a of g of x is non-zero, right? Because we can't divide by 0. All right, our next property is going to be dealing with powers. So it's the limit as x approaches a of f of x to the nth power. And so in this context, we can just pull out the nth power. And this is possible if n is a positive integer, so a natural number. Next, the limit as x approaches a of a constant is just the constant itself, right? Like thinking about it, if we like graph a constant function, it's just a straight horizontal line. And so, you know, wherever we're approaching from in terms of x, it doesn't matter. We're always just going to be approaching that constant. And then our next one, we have the limit as x approaches a of x equals a itself, right? So we can basically just plug that in when it's just x itself. And then finally, we have the limit as x approaches a of the nth root of some function is just the nth root of the limit of that function. And again, this is where n is a positive integer or a natural number. All right, so I'm going to move this up here. So here we have the limit as x approaches 1 of this polynomial, right? So we have 3 different quantities added together. So our first step, we're just going to apply rule 1, right? So we are going to separate this out in terms of addition. All right, and then we're going to apply this rule, right? So we can take the 3 here and the 2 here, and we can make those powers of the limit instead of powers of the x in the limit. And then for limit as x approaches 1 of 2, That's going to be this property, right? It's the limit of a constant, and so it's just going to be the constant itself. Next, what we can do here is apply the fact that the limit as x approaches 1 of x is just going to be 1, right, based on this property. So now we have 1 to the third power plus 1 squared plus 2, which is just 1 plus 1 plus 2, so our answer is going to be 4. All right. Our next example is going to be a little bit more complicated. So basically, with this example, we actually have to consider what the graph of the absolute value of x minus 2 looks like, because we're talking about a one-sided limit. So basically, if you look at the graph of this function, it's going to look something like this. Right? So here we are approaching 2 from the left-hand side. And so we need to think about whether the absolute value of x minus 2 here is going to be turned negative or turned positive. So, and then from there, we're just applying limit laws. So with this problem, what we're going to do is see that from this direction, approaching 2, we are coming down this line, right? So that is actually going to be negative x minus 2, right? Because that's the line we're talking about here. So let's see. So what we're going to have here is just negative x minus 2 over x squared minus 4. And then we can factor out x squared minus 4. So this becomes negative x minus 2 over x squared minus 4 factors out into x minus 2, x plus 2. And then from there, we can cancel out the x minus 2's. So now we just have a negative 1 over an x plus 2. Now, the limit as x approaches 2 from the left of x plus 2 is not 0, so we can separate this out into the limit as x approaches 2 from the left of negative 1 over the limit as x approaches 2 from the left of x plus 2. Now, negative 1 is a constant, so its limit is just going to be the constant itself. And then for the bottom, we just plug in 2 for x, and we're going to get 2 plus 2. So what we end up with is negative 1/4. All right, so I know that's a slightly more complicated example, but that's how we can apply these limit laws to certain one-sided limits. The next thing that we're going to talk about is the direct substitution property. And so the direct substitution property has to do with polynomials and rational functions. So if f is a polynomial or a rational function, and a is a number in its domain, then the limit as x approaches a of f of x is just going to be f of a. So we can literally just plug in a into the function and get our limit. So that's our direct substitution property, and we're going to see it in practice. So here we have a rational function, okay? The limit as x approaches 1 of x plus 2 over x minus 3, right? We're dividing two polynomials, so that is rational. What we're able to do here is just plug in 1 for x. We don't have to do any extra work. And so that's our answer, just like that. So this is definitely a really helpful shortcut when you have polynomials and rational functions. We can also apply it back up here to this function that we did. For the limit as x approaches 1 of x cubed plus x squared plus 2, that's a polynomial, so we just have to plug in 1. So that's definitely a great little shortcut. Anyway, that is limit laws and the direct substitution property. If you enjoyed this video, please leave a like and subscribe.